If you've worked on projects in the field of data and analytics long enough, you've probably heard the phrase single source of truth. If you've been on projects which require replicating data, you've probably also heard people voice concerns about making sure there aren't multiple sources of truth. In this tutorial, I'm going to take a vendor-neutral, tool-neutral, and cloud-neutral approach to explain how data replication is not only technically feasible, but should be viewed as a strategic advantage when implemented properly. I'll even try to explain some of these concepts with analogies to cryptocurrency and biology, just to keep things fun. Strategic data replication can improve query performance in your systems, reduce total cost of operation, help your organization scale in a global multi-cloud world, and future-proof your architecture and infrastructure for the rapidly changing world of cloud and AI. My name is Greg Beaumont, and at the time of this recording, I work for Microsoft. As I mentioned before, this is a vendor-neutral topic that I'm covering for the data community, and the contents are my own and do not necessarily represent the views of my employer. You can connect with me on LinkedIn. I have a blog to cover current and past topics intended to be educational for folks in the data community, and if you like this video, please give it a thumbs up and follow the channel. So let's start with a use case that justifies concerns about multiple sources of truth and the need for a single source of truth. This use case was valid 20 years ago, and it still happens today. Let's say you have a POS system, which means point of sale, which collects data for the sales that happen in your company. You've got 3 different people using reports off of that data. One is an analyst who uses Excel, another is a salesperson who looks at a report in their web browser, and the third is someone who I'll call a data ninja who uses an Access database. Let's start with the data ninja, because you never want to leave a ninja in the shadows too long when you don't know what they're up to. There might be a nightly refresh of that point of sale data to a data warehouse where the data warehouse also does some type of currency conversion. A nightly refresh isn't fast enough for the data ninja, so they do a manual download throughout the day and implement their own currency conversion. They then calculate the week as being Sunday through Saturday and come up with the number of $12.9 million. Now, the salesperson isn't technical, so they're logging in to view a report built for them by IT. The IT report pulls from the data warehouse that did a nightly refresh from the POS system. The currency conversion is implemented correctly, and the week is also calculated correctly as Sunday through Saturday. Because the currency conversion is different from the data ninja, the salesperson gets a number of $10.8 million. Finally, we have the analyst who also pulls from the data warehouse, but in Excel, they calculate the week as being Monday through Sunday. So the weeks are different, and they get a number of $10.5 million. 3 different reports, 3 different sales numbers. So how do you fix this problem? You cut off all access to data for the data ninja and the analyst, right? The single source of truth is preserved if only one number exists, and it is curated by the central IT team. Is that the way to go? Well, the problem with that approach is that your competitors might have smart analysts and data ninjas who do get to access data and who create a strategic advantage for their employer. Then you're at a disadvantage. The reality is that you do not succeed by having perfect data. You succeed when you use perfect data in ways that are better than your competition. Now, let's define a few terms that often get confused when talking about single source of truth. The first is data duplication. There are many different definitions of these words online, so I just picked an explanation that made sense in the context of my experience in the data and analytics world. In that context, data duplication refers to data being copied without strong governance, often manually or accidentally, and usually under some sort of independent ownership. Common scenarios that you'll see with data duplication include download data to CSV, shadow IT databases with wild and crazy transformation logic. I can tell you from experience that single source of truth DBAs are definitely not fans of anything that's wild and crazy. You might also see self-service business intelligence reports without refreshes. The data might have been correct at one time, but if it's outdated, it could be wrong. I put duplication in a red octagon because the word is usually used in the context of something bad. Next up is replication, which you can see is in a green circle because it can be good, especially when you do it the right way. Data replication is a controlled, intentional process that copies data from one system or source, such as a source of truth, to one or more systems, usually automatically and continuously. Examples would include strategic data caching, transformation optimization layers that exist to reduce expensive compute, and as I'll mention later, sometimes it can be related to multi-cloud or multi-region scenarios. Finally, we have redundancy. Data redundancy means maintaining multiple copies of the same data to improve reliability, fault tolerance, or durability. So think disaster recovery, multi-cloud or multi-region backup strategies, maybe even concurrency optimization. So duplication is usually a bad thing, and replication and redundancy can be good things. And for certain scenarios, there's a little bit of a Venn diagram overlap between replication and redundancy. Okay, so now I'm going to have a little bit of fun with an analogy. I repeat, this is an analogy. I'm not trying to equate cryptocurrency with data warehousing and reporting. I just want to give you an example of how data replication can be a net positive or even critical to another type of system. I'm not going to go laser eyes crypto bro on you here. I just think that cryptocurrency such as Bitcoin is a great example of strategic data replication. With the distributed cryptocurrency ledger such as Bitcoin, there are many different compute nodes which are completely separate from each other and which also have a copy of the ledger with all historical transactions. When new transactions happen, they get verified and recorded in the system. If a node or nodes get shut off, there are copies of the ledger attached to every other node, and there are also systems in place to make sure the ledgers are synchronized. In this scenario, replicated ledgers are a feature, not a compromise. Not only does it provide redundancy and scalability, but it also provides security against bad actors because nobody can hack all the different nodes out there. The nodes also distribute compute. If Bitcoin didn't have distributed nodes and ledgers, the entire system would be mapping back to the single source of truth of Satoshi Nakamoto's laptop, which hasn't connected to the network in over a decade. Another example of strategic data replication is with biology. Again, this is a fun analogy, and I'm not trying to make a like-for-like equivalence. Living organisms are conglomerates of cells, most of which contain a complete copy of the source code for the entire organism, which is DNA, or deoxyribonucleic acid. I was a biology major, so I can say that without getting tongue-tied. In the diagram, I'll be attempting to show a small cluster of cells from a baby. I chose a picture of a baby because babies make people happy. And each cell contains a copy of the unique DNA for that organism. Another even deeper fun analogy that might be a little bit of a stretch, but if you were to describe the physical world from the perspective of a programmer, DNA might be considered a third-generation programming language. First generation would be quantum mechanics and the information stored at the base level. Second generation would be chemistry that orchestrates what's going on at the quantum level. And third generation would be complex organisms that arrive from the programmatic instructions of chemistry, which is the DNA. If there was only a single source of truth for your DNA and it only existed in one cell, you'd be in big trouble if that cell ever got damaged. Also, the system of strategic DNA replication allows it to perform different tasks in different parts of the organism independently. And each cell has its own chemistry to fuel that work. Thus, in some ways, a cell has isolated compute and performs a similar function to a cryptocurrency node. You can think of the cell itself as a node and the DNA as the ledger. There are even cellular processes in place to self-destruct the cell if the DNA were to inadvertently or mistakenly change. If those processes didn't exist, we'd all be in big trouble. So strategic replication of data for your organization can have benefits analogous to cryptocurrency and biology. Again, fun analogies, trying to explain the concept, not saying they're the same thing. So where did the idea that replication is bad come in? Let's go back to the on-prem days where people argued about Inman versus Kimball. As a short summary, Inman advocated for a top-down model, starting with the source systems to ensure that you had an accurate single source of truth, and then built everything else off of that, while Kimball took the approach of starting with the business to define their needs, create conformed dimensions and purposeful fact tables, and work your way back to the source systems. Most organizations still use some sort of hybrid of these two today. With on-prem technologies, storage was also expensive, and it was tied to compute for relational databases. ETL also used a lot of compute, so ensuring that everything was written very efficiently was of the utmost importance. Also, access databases and spreadsheets were everywhere, with analysts and data ninjas making the type of mistakes that I talked about earlier. So how are things different today versus back then? Compute costs are still expensive, but far less expensive than they were 20 years ago. Compute is also more scalable with cloud technologies. You can run it for 2 hours and then turn it off. You no longer need to own it 24/7. The storage cost of data has come down dramatically to the point that it is often a single-digit percentage of the total cost of operation. Cloud technologies have dramatically increased the speed of development. Projects that used to take months now take days or weeks. Technology keeps evolving and isn't going to slow down anytime soon. I can remember the days where you could read a book on SQL Server and nothing would change for the next 2 years. Today, if you go on vacation for 2 weeks, you probably miss something important. Now let's move to a fictional real-world example, starting with a reporting data warehouse that is in the East USA region of a particular cloud vendor. It's the source of truth for 3 different reporting tools, one of which is in Europe. The warehouse provides reporting data for users in both North America and Europe. First of all, you run the risk of a high concurrency bottleneck if too many users are hitting the same endpoint at the same time. With 3 different reporting tools, there could even be very different queries hitting that endpoint, which could limit the utility of query caching. There might also be a bottleneck if one of the tools is generating inefficient queries, which is very common with business intelligence tools. I don't dive into it in this report, but in addition to data replication, replicating and validating the logic of your semantic layers is also of the utmost importance. I take a deep dive into this topic and how it impacts your architecture for AI and agentic solutions in an older video on my channel named Fabric Semantic Models Add Good Math for AI Agents, Azure AI Foundry, and Copilot Studio. It's possible that some of the reports in this example might work fine. Maybe they're generating simple queries and they don't have a lot of users using those reports concurrently. But then there might be another reporting tool used by the European team, which has a bottleneck due to transatlantic networking. If all the reports are pulling data from a cloud data center in the United States, every single query is going to have to cross the ocean. Also, I'm not an expert on the topic, but there may be regulatory GDPR concerns in Europe if you're reporting in Europe and the data is living in the Eastern United States. So how can strategic replication help? Well, if you take that reporting data warehouse in East USA and you strategically replicate some of that data somewhere else, it could be a subset of that data. It doesn't even need to be all of it. Maybe only 3 years instead of 10. Maybe only 30 tables instead of 100. But with modern tools, it shouldn't be hard to make sure that the data that is there matches the data from your source of truth. Then the reporting tool, which uses that replicated subset of the data, will be running all of the queries against the replica rather than the data warehouse, which is technically the source of truth. This would be a classic case of strategic data replication. Now, you could also make a replica in Western Europe, and maybe due to GDPR concerns, this replica is also a source of truth for sensitive European data. In this case, not only would you be implementing strategic replication, but you'd also be creating redundancy. If a massive infrastructure outage in the United States caused the Eastern US data center to go down, everything could still be working, theoretically, in Western Europe, So you then have 3 different tools that hit perfect replicas of the data in a way that distributes the compute, optimized for geographical location, and in the case of a subset replica, reduces the size of the query results in order to make things faster and cheaper. Another important consideration is how long it takes for the replica to populate. If you're only running an update every night, then there may be a period of time for which the database won't give you the exact number as the source of truth. But there are technologies today that can minimize the latency for this replication to happen. Just like cryptocurrency, you can keep your replicas matching with near real-time latency. Now, let's zoom out and take a look at how that model might scale. You've got a reporting data warehouse in East US, which is in sync with the replica in West Europe, which might also be in sync with another replica that's in a completely different cloud. So at this point, not only do you have replication and redundancy in Cloud A, but you also have multi-cloud redundancy by involving Cloud B. You could then have a customized layer that only holds the necessary data that's being used by the semantic or logical layers. Again, making sure that your logic aligns when you're using different tools is extremely important because you want the numerator and denominator of calculations such as gross margin to be calculated the same way every time. Even if the underlying data is the same, you need to use the same math equation in all of the different tools to get the right number. Per the diagram, you could then also have 3 different reporting tools in your organization. One that runs exclusively on Cloud A and with data from the Eastern US data center. Another reporting tool, which we'll call Tool B, that runs off of data both from Cloud A and from Cloud B. And then you might even have reporting tool C, which is only running in Cloud B for Western Europe. The key takeaway message is that as long as you have a solid and scalable mechanism for replicating data from your source of truth, you can also have redundancy, scalability, compute optimization, and an optimized total cost of operation. Always remember that in the age of lakehouses and modern cloud architectures, storage is cheap, compute is expensive. Also, this model can be integrated with agentic solutions having large language model use cases. So you're future-proofing your environment by making sure that what you do doesn't have to be rebuilt or completely redesigned as agentic technologies evolve and you start adding them to your ecosystem. Again, I dive into that topic in depth in some of my previous videos. If you like this video, please let me know in the comments, give it a like, and follow the channel. Also, if you have suggestions for future topics related to this video, please pass them along. Thank you.